Okay, so today I'm going to take up the half adder from last week. So the one thing we need to realize that we only have two inputs, A and B, but we have two separate gates that they need to go to, and then we have two outputs, X and Y. I'll flip back and forth for this, but the first thing I need to know that I need an XOR gate and an AND gate. So I'm going to need two different chips on Tinkercad to wire that up, and I'm also going to need two LEDs, X and Y. So what I've also created is just a basic breadboard power supply ready to go. One thing that I can do very quickly, if I click duplicate, what it'll do is it'll actually open up a copy of this circuit, and then I can make changes to this circuit, and it won't change the old one. So whenever I'm starting a new circuit, this will be helpful. I'm going to do the half adder. So in this case, one of the gates I'm going to need is the AND. So I'm going to drag that on. Right away I'll give it power in the top left corner, and I will give it ground in the bottom right corner. I'm also going to need an exclusive OR chip. So I'll grab that and drag that on as well, again giving it power in red and ground in black. Now the one thing I need to realize is there are two inputs, A and B, but the input for A goes to the first pin on both chips, so that signal is getting sent to the first input on both chips. So if I do a wire to the first pin here, A, I can also take that signal and send that same signal over to the first pin A of the second chip. I'll also do a second input wire for B, and then I will do the same thing from that same column. I will jump that over to B of the second chip. So now effectively at this point I've wired up the inputs to the two gates. So now I just need to worry about the outputs, which we are going to use LEDs for. So I'm going to need two LEDs. The one thing I want you to realize is that your final output of Y should always be the far right. Any other intermediate gates can be to the left of that final output Y. So now that I know that this is Y and this is X, I need to realize that the output from the exclusive OR gate needs to go to the Y output. So in this case, the output from here goes to Y. Now to finish that, I need a resistor. I'll drag that resistor in, and again need to terminate that to ground to complete the circuit for the LED. So that takes care of the exclusive OR. The next thing I need to do is do the output from the AND gate. So in this case, the AND chip is here, so the output will go to the yellow LED. And again, I need another resistor, and then I need to terminate that LED to ground. So essentially what I'm saying is that these two values for A and B are the inputs that I'm adding together. So for example, if right now they're both set to 0, this half adder should say 0 plus 0, and when I turn that on, you can see that neither of my outputs are on. When I turn A to 1 and leave B at 0 and I run that, you can see that my Y value is now on. So in this case it's saying 1 plus 0 is 0, 1. Obviously if I flip A and B, so B is on and A is off, I should get the same result. I'm going to show you what it should give me when I turn both on. So again, I'm saying 1 plus 1, and what I should get is 1, 0. So I can see that X is on and Y is off. So that's me building and testing the half adder.